All right, the last thing we're going to look at today is the foldable, that is the solving systems of equations using the different methods. So the first one we're going to look at is graphing. When we graph, they both have to be in the form of y equals. So both equations need to be y equals. So if they're not both in y equals, that's the first thing you're going to need to change. So if you look at this first one, then it's 2x plus 5y equals 11. I'm going to need to fix that one. So 2x plus 5y equals 11. So I'm going to subtract the 2x from both sides. 5y equals 11 minus 2x. And then I need to divide by 5. So I'm going to get 11/5 minus 2/5 x. Alright. So those are my two linear equations because the second one was already in the correct form. So now, in order to find where they intersect, I'm going to graph both of these. So we'll start with the second one that was already in y equals form. So -5 means I have a y-intercept of -5. So 1, 2, 3, 4, 5. And then this is saying I have a slope of 1/2. So up 1 over 2, up 1 over 2, up 1 over 2, 1 over 2. Right. So there is that line. Now the other one, I have a y-intercept of 11/5. So 11/5 is going to be 2.2. So my y-intercept 1, 2, 2.2. And then I'm going to go down 2 to the right 5. So 1, 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. And then if I connect those lines, or those points, sorry. I can see that my two lines intersect right here, which is the point 1, 2, 3, 4, 5, 6, 7, 8, -1. So 8, -1 is my solution. Okay, so that is using our graphing method. So our next method, if we flip, is going to be tables. So remember that when we look at tables, the solution is where I have the exact same ordered pair. So if I look at my table, I'm looking for where does this table and this table have the exact same ordered pair. So -1 isn't even over here. We got a 0. It's not the same. Hold on just 1 second. Okay, so as we go down, so 0, -6, 0, 1 doesn't match. 1 isn't even over here. 2, 3. So 3, 0. Let's look at what it is over here. 3, 0. So since this one is 3, 0 and that one is 3, 0, that means my solution becomes the ordered pair 3, 0. Okay? Alright, so when we use substitution, we need one of our equations to have a variable by itself. So one equation needs a variable isolated. So if I look at the two I'm given, neither one of these has a variable by itself. We always want to pick the one that's probably going to be the easiest. So if I look at this first one, there's no coefficient with the y. So getting y by itself right here is going to be as easy as just moving the 3x to the other side. So 3x plus y equals 8. I'm going to move that 3x over. So y is equal to 8 minus 3x. Okay, so once I have a variable by itself, then you're going to plug one equation into the other. So now since I have y by itself, this is telling me that y is 8 minus 3x. So right here, instead of writing y, I'm actually going to write 8 minus 3x. Once I've done that, I only have one variable. I only have the x. So I'm going to solve for x. I'm going to combine my like terms. Add 24. So I get 11x equals 33. I'm going to divide by 11. So x is 3. I should say solve. Now that I have x, I only have half my answer. So you have to plug that solution back in to get the remaining variable. It doesn't matter which one you plug it back into, but since this one's already set up to get y by itself, I'm going to go ahead and plug 3 in right there. So I get 8 minus 9, which is a negative 1. So my answer is 3, negative 1. Okay? All right. Elimination is also a combination. You could use matrices with it. You can use either one. Elimination, you really need opposite coefficients. So one needs to be positive, one needs to be negative, and they need to be the same number. So if I look at this one, that doesn't happen because my x's are a 3 and a 2 and my y's are a 3 and a 1. Granted, these are opposite. So if I wanted to solve my elimination, I could multiply this top equation by 3 so that they would match up. But if I can't, then I can plug these into the matrices. First thing I want to do is actually pull my numbers out. So 3, 1, 8, 2, negative 3, and 9. So I'm going to plug it into my matrix. So I'm going to do second x to the negative 1. And then I'm going to arrow to edit. And hit enter. Then I enter my rows by columns. So it is a 2 by 3. And then enter the matrix that you wrote above. So 3, 1, 8, 2, negative 3, 9. All right. Now, second mode takes you back to the home screen. From there, I'm going to go to second x to the negative 1. Go to math and find RREF. It's letter B. And hit enter. Then go second x to the negative 1 again. And enter. Enter one more time. And I should get a matrix with zeros and ones. and this column right here is my solution. Okay? So elimination and matrices go together. So you can choose which one you want to do. Special cases typically occur when it's either parallel lines or no solutions. So if I'm going to do this top one right here, I would put this in your matrix. So second x to the negative 1, edit, it's a 2 by 3, so I'm going to enter my new numbers. And then second x to the negative 1, RREF. Alright, so when I do this, and I get zeros all the way across on the bottom, this is telling me that these two equations are the exact same line. So, this first one, I got 1, 0, negative 1.75. So this is infinite. So those are the same line. Now, if I do the other one, and I actually, I can use substitution. So, negative 6x plus 3, 2x plus 11 equals 21. Negative 6x plus 6x goes away, and I'm left with 33 equals 21. Remember, if I end up with an untrue statement, this means there's no solution. They're parallel lines. Okay? And that is it for solving systems of equations.